I'm going to introduce Dr. Jamie Jonker, who is coming to us from National Milk, who's going to talk about environmental chemicals affecting the food supply. This has been something that's been in the news quite a bit recently. As the Chief Science Officer and Vice President for Sustainability and Scientific Affairs with NMPF, Jamie has general responsibilities in sustainability and scientific affairs, including animal health and welfare, animal biotechnology, dairy farm biosecurity, dairy farm air and water quality, dairy farm sustainability, and technical service issues. He is also involved in coordinating relations with the Federation's Animal Health and Wellbeing Committee and Environmental Issues Committee. Dr. Jonker is active representing the Federation on numerous national and international committees, including the U.S. Animal Health Association, the International Dairy Federation, the World Animal Health Organization, and CODIS Alimentarius. In 2019, he was appointed to the USDA's Secretary Advisory Committee on Animal Health. He serves as on the U.S. Animal Health Association Board of Directors, and in 2020, he was elected as chair of the IDF Science Program Coordinating Committee and the IDF Board of Directors. Dr. Jonker also served on the IDF Delegation's Task Force on Animal Feeding and the Codex Ad Hoc Intergovernmental Task Force on Antimicrobial Resistance. In 2021, he was appointed as an ex officio member of the USDA APHIS Environmental Veterinary Services National Animal Disease Preparedness and Response Program Consultation Board. Jamie received his BS degree and MS degree from Cornell University, his PhD from the University of Maryland, and prior to joining NMPF, his career included 6 years of experience in agricultural policy, including service at the National Academy of Sciences, the U.S. Environmental Protection Agency, and the U.S. House of Representatives Committee on Agriculture. So welcome, Jamie. Thank you for joining us. I will say that in addition to all of this, Jamie probably takes more plane flights pre-COVID. He took more plane flights than anyone that you know, and he documented it in an interesting way, but that's all stopped, right? Where are you today, Jamie?
Today I am in Cambridge, Massachusetts. I have done 14 flights this year. In a normal year, I would be well over 100 by now. Thanks, Donna. Thank you for inviting me to talk today. Let me go ahead and see if I can share my screen to bring up slides so that I can control them and don't have to tell you to advance for me. There we go. It looks like it's going to work here. I appreciate the opportunity to talk here today. I've relabeled my presentation just a little bit. I'm going to be talking about environmental-ish contaminants in the dairy-ish food supply chain just because of my background. And I think that this is, it's an interesting coincidence in the timing of my presentation here today, because it's also the same time that the United Nations Food System Summit is occurring in New York City during the general sessions of the United Nations, but also around the world. And part of the elements of the United Nations Food Sustainability Summit is looking at the resiliency of the food supply chain, including assuring that the food supply chain is safe. And so it's just coincidence that both of these events are happening today, but they do link together in some aspects. So contamination occurs along many points in the food supply chain. So you have it in the production side. It can happen in processing, distribution. It can happen at retail, restaurant. It certainly can happen in food service, and it definitely does happen in people's homes. And I'm going to talk about things that occur at some of the earlier parts of this in that environmental-ish contamination aspects. I'm not going to talk about how we need to continue to reinforce with our consumers, particularly at home, how to properly handle their meat and eggs and milk and vegetables and such. That would take far too long of a time than I have here today. But when we talk about food contamination, we're really looking at kind of three general categories. There's biological contaminants, there's physical contaminants, and there's chemical contaminants. I'm going to talk today a bit on some chemical contaminants and a bit on some biological ones. I'm not going to talk about physical contaminants today. What I am going to talk about is I'm going to touch upon a few different subjects here. I'm going to talk about PFAS. I'm going to talk about heavy metals, radionuclides, and pesticides under the guise of the FDA Total Diet Study, dicyandiamide, DCD for short, because it's far too hard for me to pronounce, mycotoxins, bacteria, and antibiotics. So the first one I'm going to talk about is the PFAS and PFOS, and just kind of putting together here what are the PFAS chemicals. There are more than 5,000 man-made chemicals that stay in the environment forever. So they're persistent pollutants in the environment. They're used in nonstick products such as the frying pan that you might use to fry your eggs, firefighting foams, food packaging, water repellent materials, waxes, and polishes. And they largely enter the environment through sewage sludge, industrial waste, unlined landfills, firefighting foams, and fracking. And because of the ways that it's entering the environment, it's generally considered, or at least I would say it's considered from my organization, that it's a drinking water issue. It's a drinking water issue that at times has affected some dairy farms. So what types of dairy farms has it affected? It's affected 4 dairy farms in the US. They've been unable to ship milk because of high PFAS levels found in their milk. Last month, FDA released test results for 167 processed foods, including some dairy foods. They found 164 were non-detect, but there were low levels found in 3 products: canned tuna, fish sticks, and protein. Previously, the FDA has released results from a total dietary study, including testing foods for PFAS. 13 dairy foods were tested, all came back non-detect. And this is the 3rd round of testing where dairy foods have come back non-detect. Recently, the Department of Defense has sent about 3,000 letters to ag operations, including some dairy farms that are near military bases, stating that they may have potential PFAS contamination. Of the 4 farms that have had PFAS issues, one in New Mexico is due to a groundwater issue related to a military base. And then there have been a couple of farms in Maine, which appear to be due to issues related to the spreading of sewage sludge on fields, in some cases, a decade or more ago. So how are they regulated? Currently, EPA only has an advisory level for PFAS, and they may issue MCLs for water. If so, the question is, which PFAS chemicals, or will it be for the entire class of 5,000 plus compounds? Then the question becomes, will EPA add PFAS chemicals to the Superfund list? And if so, what will a farmer's liability be on his or her farm if it's declared a Superfund site? Certainly from a national milk perspective, we don't think that declaring PFAS chemicals to the Superfund list is a good idea because of that potential liability for dairy farms that may be unwittingly brought into an issue of having a PFAS contamination. We do have issues where, particularly in that farm in New Mexico, where they have been being paid through the Dairy Indemnity Protection Program for their milk, which has been contaminated because of the PFAS in the groundwater for their milk, but the current program does not allow for a herd buyout. And so we have requested USDA to modify that, and we hope that they will. Will FDA establish limits for food above which food is adulterated? And if so, are they different for each food based upon consumption patterns? And that's a bit about the total dietary study, which would be what is the exposure of a person to potentially PFAS in their diet through the various foods that they consume. A question happens, will Congress make scientific decisions that are normally left up to regulatory agencies? There have been a number of bills introduced into Congress that would regulate PFAS without regard to the actual scientific information. And I think we could question, does Congress really have the competency to make scientific decisions? And then finally, we've had some difficulty with the Department of Defense on wanting to cooperate with agricultural operations and do the right thing in the areas where they have contaminated the land and groundwater, which is such things as purchasing the land and providing clean water. They are required to provide clean water to people that are in the areas that have groundwater affected by PFAS due to Department of Defense uses on military bases. But they are not specifically required to actually do that for livestock. Moving on, I'm going to talk now about 3 items that are included in part of the FDA Total Diet Study. You may know it more as the Market Basket Study, which is an ongoing FDA program that determines the level of various contaminants and nutrients in food. The food list represents a typical American diet and is updated periodically to reflect changes. And they do it across a number of different categories of people. So it's not one diet for every American. It's actually a number of diets for a number of classes of Americans, such as children, elderly, people my age that are somewhere between 20 and 60, and so on. The foods are prepared and analyzed as consumed to provide realistic estimate of dietary exposure. And the reason that the FDA Total Diet Study is done is to determine background levels of contaminants in a wide range of food. This helps focus resources for FDA compliance programs. It offers exposure estimates to indicate potential risk and identify main dietary sources. And that information used by compliance program to design their sampling plans. So one of the things that is analyzed is heavy metals, through the Elemental Analysis Manual for Food and Related Products. This is to generate information on the concentration of toxic elements in selected foods and to estimate dietary exposure of those elements, particularly in sensitive populations, the elderly, the young, or the immunocompromised. It also helps to identify the major dietary sources of the contaminants, which can aid CIFCIAN in directing its efforts to reduce these levels. On the radionuclide side, there's really 2 different ways that they enter the food chain. There's natural radioactivity, which is environmentally in the background. And in places with high natural radioactivity, it can enter into the food supply chain from water and rocks into fish, from soil into crops, fed into livestock, and then from the livestock products fed to the animals. But then there is also the potential for radioactivity entering the food supply chain due to the proximity to nuclear power plants. That's the pictogram that you see on the right-hand side, where you have radioactive material coming from a nuclear power plant and then being deposited downwind. This can contaminate crops that go into animals. It can contaminate water that is used for drinking or for food processing or for food cooking, and can contaminate fruits and vegetables, fish, and other food items. The Nuclear Regulatory Commission does require that reactor operators must monitor and report radiation levels in the environment. And they do environmental samples on a routine basis. They come from the air, surface water, things like ponds, streams, and lakes, groundwater, drinking water, fish, shoreline sediment, and as you see there, highlighted in bold and italic, milk. So milk is one of the products that they look at. So they look at farms that are in close proximity to a nuclear reactor and do milk samples from them. The nuclear power plant that you see there is in Pennsylvania, and the top part that you see there is their most recent report, where they talk about milk samples were being collected bi-weekly when cows were on pasture and monthly when cows were not grazing on pasture. And then those results are reported into the Nuclear Regulatory Commission, and any results that are out of line signify a potential issue with the power plant and the necessity to look at different ways to assure the food safety of the products within the downstream area of that nuclear power plant. Then the third one I'm going to talk about in the total food diet study is pesticides. So the FDA pesticide residence monitoring in food has the goal to carry out selective monitoring to achieve an adequate level of consumer protection. FDA samples are primarily of the surveillance type, meaning there is no specific prior knowledge or evidence that a particular food shipment contains an illegal residue. However, FDA's monitoring is not random or statistically designed. Rather, emphasis is given to the sampling of certain commodities. And here you can see results from FDA's most recent report. I believe that this represents 2018 data, and you'll see there that there are thousands of samples that are taken. What you will notice in the dairy and egg category, so that will be dairy and eggs combined, a total of 11 samples. And you may ask, well, is that really enough samples to make a determination as to whether or not there's a pesticide carryover issue into dairy products that could result in a food safety issue? Well, it may not be enough there, but coinciding with this is the USDA pesticide data program. This program from USDA enables the U.S. Environmental Protection Agency to assess dietary exposure of hundreds of different pesticides, insecticides, and rodenticides. It helps facilitate the global marketing of U.S. agricultural products and provides guidance for the U.S. Food and Drug Administration and other governmental agencies to make informed decisions. So this information is utilized along with the sampling that the Food and Drug Administration does. The most recent whole milk survey was from 2017. There were 413 pesticides that were included in the analysis. There were 711 samples taken quarterly around the US. Not every sample was analyzed for every pesticide, but most samples were analyzed for most pesticides. There were more than 275,000 residue tests conducted. There were only 17 residues that were found in these milk samples, and these are samples off the store shelf and not at the farm level. 17 residues were found. They were all found for one specific pesticide, but all of those were found to be below the EPA tolerance level. And so FDA takes these various data streams that come into their total diet study to make an analysis on the overall safety of individual parts of the diet, plus the overall diet that Americans are consuming. I'm going to switch gears a little bit here and talk about DCD. I'm not going to try and pronounce the name again because, as you heard when I first started, it's very difficult. And I'm going to hop outside of the US and take a little trip down to New Zealand and talk about something that happened there just about a decade ago. So DCD is commonly used in fertilizer formulations, not just in New Zealand, but in the US and elsewhere in the world. What it is it's a nitrification inhibitor. It helps to slow the release of the nitrogen to better time it to the needs of the crop that has been fertilized. But something happened in New Zealand that was unexpected. So it was being used on pastures in New Zealand to prevent nitrate from seeping into rivers and lakes. So it was being utilized in their dairy pasture-based systems to prevent a surface water contamination issue. However, in September of 2012, multiple samples of processed dairy products manufactured in New Zealand were found to have a DCD contamination to them. This led to the suspension of the use of DCD on pasture in January 2013. And to my knowledge, that suspension continues to this day. So here we had something that was being utilized for an environmental issue, which is the potential of nitrates from animal waste running into surface waters and having an unanticipated effect of becoming a chemical contaminant in milk. Moving on to mycotoxins, chemicals, but naturally occurring chemicals. Mycotoxins are a secondary metabolite of fungus. There's been over 300 identified, and many of them are toxic to humans. Just over here on the right-hand side of the slide, some of the ones of more concern to humans in places where they have effects. There's aflatoxin, fumosin, zerolinones, ochratoxin, and others that have a variety of health impacts, deleterious health impacts on people. They can also have deleterious health impacts on animals as well. And they can be found in animal feed. We can find alkaloids in our grains and grasses. We can find aflatoxin B1, particularly in corn and corn silage, zerolinone in corn and corn silage, ochratoxin in cereal grains and coconut. And it's an issue that happens worldwide. So this is the Biomin Mycotoxin Annual Report from 2020. If you go online, you can download their report and look at the prevalence of a variety of different mycotoxins in animal feed. What happens in animal feed is that when the animal consumes it, it can be passed along in the animal product. Our issue in the dairy sector is the consumption of aflatoxin. Aflatoxin B can end up in the mammary gland, transformed into another form of aflatoxin that has significant health consequences for people. So there are limits in the amount of aflatoxin that can be in a feed fed to a dairy animal, as well as a limitation on the amount of the aflatoxin that can be in milk. And so here you see the FDA aflatoxin action level in food and feed. You'll see that corn and peanut products here for beef cattle is 300. But corn products for poultry is only 100. This is a consequence of the differing ways that those animals uptake the aflatoxin and transmit it in their products. At the bottom there, you see milk has an aflatoxin M1 tolerance of 0.5 parts per billion. Moving a little bit off of kind of the chemical arena, but still something that can result from the environment is bacterial contamination. So bacterial contamination, much like that very first slide where I talked about where contamination can occur at almost any point in the food system, bacterial contamination can occur at all of those differing points as well. You can have bacterial contamination that's in the milk. This is one of the reasons why the pasteurized milk ordinance exists, where we end up pasteurizing the milk and doing somewhere between perhaps an 11 and 14 log reduction in the bacterial and other pathogenic load within the milk. It's not a kill step, but it is a significant risk mitigation step that happens in our dairy supply chain, making our milk and dairy products much more safe compared to the consumption of raw dairy products. But you can also have bacterial contamination that comes from water. Irrigation water that's been utilized on particularly leafy green crops has resulted in a variety of foodborne outbreaks around the US. We also have bacterial contamination that can happen from the meat side of our livestock as well. And here's just a number of multi-state outbreak investigations that CDC conducted in 2019 for a variety of different bacterial outbreaks. You see such things as hard-boiled eggs, which is kind of a kill step, so that may be a contamination during processing. You see the Fresh Express sunflower crisp chopped salad kits. I believe that one was attributed to surface water or irrigation water. You see a romaine lettuce one there. You see a ground beef with Salmonella Dublin. That was actually an outbreak linked to cull cows It was unclear whether it was dairy or beef, as I recall, but certainly a linkage to cattle production, and a variety of other bacterial contaminations that happen at a variety of places in the production stream. Finally, I'm going to close out here on antibiotics. If you are in the dairy industry, you're very well aware of the Appendix N of the Grade A Pasteurized Milk Ordinance, which requires all bulk milk pickup tankers to be screened for beta-lactam residues. Within there, it also allows the FDA commissioner to require additional testing for other antibiotics if the commissioner believes that there is a food safety risk. So all milk is tested for beta-lactam residues. There are also tens, if not hundreds of thousands of tests for other antibiotic classes as well, the largest being tetracycline and the sulfa drugs. And all milk with a residue is disposed of and cannot enter the commercial milk supply. This, for me, has been a really interesting slide to watch over the years. This data comes from the National Milk Drug Residue Database, published annually through a contract with FDA. We see here back in 1996, about 0.1%, or 1 out of about every 1,000 tanker trucks tested positive for a drug residue, which at the point in time is a small number, but is a point where we could see that there was still room for improvement. In 2020, the year for which we have the most recent data, it's now 0.01%. So about a 99% reduction there. And we've gone from about 1 in 1,000 tanker trucks to about 1 in 10,400 tanker trucks. So a very nice decline that you see here. I think there's several things that have caused this. Probably one of the biggest ones is that if a dairy farmer has a residue that is attributed to them, they're responsible for all of the milk that's destroyed on that tanker, whether it's a single tanker that comes from their own farm, or if the tanker has gone to 5, 10, or 20 other farms. There's also the potential, if a person is a habitual violator, that they can actually lose their license to sell milk. I would also like to think that what the industry, the state, and our federal partners have done in terms of education about the appropriate and responsible use of antibiotics, going back to the original 10-point residue avoidance plan, which has morphed itself into the milk and dairy beef residue avoidance manual, has had a part in this as well. We also do residue testing in the tissue of our animals that are sold. Here I'm going to talk specifically about dairy beef, but this same type of residue testing is done for conventional beef, and for swine, and for poultry, and for small ruminants. So antimicrobial residue test results, residues are tested in accordance with the USDA FSIS National Residue Program for meat, poultry, and egg products. And each year they come up with a residue sampling plan. They have what's called scheduled sampling, which is they randomly select animals that have passed antemortem inspection and test those for residues. So antemortem inspection is what you're seeing over here on the left-hand side of the slide, where the animal has been euthanized and the carcass is hanging on a rack. They also do targeted sampling. This is risk-based inspection generated on the sampling of animals suspected to have residue violations. This is done both targeting animals before they are euthanized and after they are euthanized for slaughter. So an animal that's in a pen that looks sickly, or maybe has a swollen udder, may be targeted for testing. But once the animal's up on the rack with the antemortem inspection, they also look for things like residue injection lesions. And much like milk, all meat with a residue is disposed of and does not enter into the commercial supply. What I've got here are the two elements of the tissue residue violations that I would say are attributable to our dairy system. We have the bob veal tissue residue violations. Bob veal are those calves that go to slaughter shortly after birth, rather than what would be called fed veal, which would be calves that would be fed out for a number of months prior to being slaughtered for veal. And then on the right-hand side, we've got the dairy cull cow tissue residue violations. USDA reports these numbers annually, and we've seen a great reduction on the bob veal side from 2014 to 2019, which is the year of which the most recent data is available. That reduction there has been in excess of 50%. And a big portion of that is that orange bar, the neomycin. And that coincides with a change from the Food and Drug Administration about the availability of neomycin going from over-the-counter in medicated milk replacers to requiring a prescription. My hypothesis here is that there was a fair amount of inadvertent use of medicated milk replacer for those male bob veal calves before they were sold. And because we went from over-the-counter to prescription, there was a significant change in the marketing of medicated milk replacer, not entirely disappearing from the market, but going from being the standard product to being the non-standard product line. That I think a fair amount of that and that unintentional issue of feeding a medicated milk replacer has decreased the issues specific to neomycin. On the dairy cull cow side, we see a reduction, not quite as much as we saw on the bob veal side, but still about a 40% reduction here from 2014 to 2019, which in both of these cases, those types of reductions in such a short period of time, I think are quite remarkable. On the cull cow side, it's about 1 in every 8,000 dairy cull cows that is found to have a tissue residue violation. The issue for us on the dairy side is that bob veal and dairy cull cow tissue residue violations account for about 75 to 80% of all tissue residue violations that USDA finds. And so that's not just in cattle, so it's not just dairy and beef animals, but it's swine and poultry and small ruminants. It's everything that goes through a federally inspected slaughter plant. And so while there's a good story here on the dairy side about the reductions that have occurred recently, it's still an outsized proportion of the overall residues that are found. And finally here, I want to wrap up with an additional element on the antibiotic side as a potential route of contamination. I don't think it's one that has panned out, but one where there was enough concern that FDA did a sampling assignment. And this is the use of antibiotics in ethanol production. Antibiotics like virginiamycin, penicillin, and erythromycin have been used in some ethanol productions to help control or prevent bacterial contamination in their fermentation processes. And so at the end of this, you have two things. You have the ethanol that goes into the energy system, and then you have the distiller's grain byproduct, which is fed to poultry and livestock. There was enough concern about the potential of the carryover of antibiotics in these distillers' grains into the animal and then subsequently into the animal products for human consumption, that in 2010, FDA conducted a sampling assignment to determine whether or not this is truly a viable pathway for a food safety concern for humans. They did have 4 samples that had quantifiable residues for antibiotics, but none of the samples had an FDA actionable residue, meaning that they determined that there was not an issue for human food safety through this process. I bring this one to your attention, not because it has occurred, and this is quite a while ago, but I bring it to your attention because there's a lot of different places where you could have a potential for contamination of the food supply system. And in this case, we were looking at a process that is tied to part of our energy policy that could have had an unintended consequence of causing a food safety issue for our livestock products. Through diligent work of the Food and Drug Administration and the ethanol producing community, we determined that did not actually rise to the level of a food safety issue. But it is interesting to think about all the different moving components within our food production system here in the US and around the world, and the many different places where contamination could occur. That is the last one of my slides. It's been kind of I hope, an interesting presentation for you. There's, like I said, a variety of places where contamination can occur and a variety of types of contaminations that can occur. Ultimately, what we're looking for is to take these potential vulnerabilities where contamination can occur and apply risk mitigation to minimize the risk of those contaminations actually rising to the level of a food safety concern. And I'd be happy to take any questions at this point in time. I think we have a few moments for that, Donna.
Yes. Thank you. Thank you for that. But your presentation right after Ryan's presentation, like, I feel like made us very, very aware of many things to think about that we don't think about every day. There's a lot going on out there. Vicki, do you have your hand up?
Yeah, I just had a question. I was curious, you had mentioned the nuclear power plant in Pennsylvania where they had tested milk from nearby cows. Did they find anything in that milk?
So the testing required by the Nuclear Regulatory Commission is ongoing. And so they've been testing, that power plant, around that power plant in Pennsylvania for decades. They have been testing milk around power plants all around the US for decades. And we actually saw, we don't see issues, to my knowledge, from our US nuclear power plants, perhaps with the exception of the 3 Mile Island incident back in the late 70s, early 80s. Interestingly enough, we did pick up in some of the testing from plants out on the West Coast, I guess it'd be about like 5-6 years ago now, no, actually about 10 years ago now, when the Fukushima power plant in Japan had its significant issue with release of radioactivity into the atmosphere. You could pick up background levels in the Pacific Northwest, in the milk and in the other monitoring that happens around nuclear power plants from that release in Japan. So it is very sensitive, and I think it is a demonstration of the safety that we have with our nuclear power plants here. So that's probably the best I can answer about that. The reports are available online at the Nuclear Regulatory Commission, so you can go online and look at all of the reports that are published on, I think it's either quarterly or semi-annual basis for each of the nuclear power plants around the US.
Okay, thank you.
Yeah, and I don't know, it's been quite a while. Maybe someone from Ag and Markets could talk about, I know within my career that they have done milk sampling in New York State around the power plants in like concentric radius to see if there was any contamination. It's always a little scary when they do it. You don't know what they're going to find, but it's been okay so far. There's a question from Steve Murphy to everyone. He says, very nice summary, thank you. From a food safety plan perspective, do you have thoughts on which of the categories you covered should be identified in a hazard analysis and or addressed in a food safety plan for most dairy operations? For example, based on USDA data, pesticides do not seem to be reasonably likely. Are they even worth identifying, or if it depends? And then radiological is another that seems to be reasonably unlikely, yet everyone seems to think it should be addressed. And then I have one more question. You said there was only one pesticide that they found levels of, and I was curious to know which one it was.
I'll answer your question first, Donna. it's in that report from 2017. I believe it began with an F, but I didn't memorize it. As I looked at the report, I just thought it was interesting that they highlighted, was that 413 pesticides that they looked at. So over 275,000 analyses, and only 17 were found. They were all found, I'm pretty sure, for this one pesticide, and they were all below EPA tolerance levels.
Yeah, but it wasn't Roundup.
It was not Roundup. It was not something that I was familiar with as being utilized a lot in crop production for dairy. Then on the hazard analysis part, I'm not an expert in this, so please take my comments here gently. But I do think that when we look at the results from like the PFAS work that's coming out, the pesticide information that comes out, there are probably things that are less likely to occur. We still need to do this continual background monitoring to make sure that the situation hasn't changed. But when we look at from a dairy side, I think antibiotics continue to be something that we need to continue to do testing on. We can have questions as to whether or not it needs to be every load for beta-lactams, or go back to the drug of the month or some other combination. But I think that there's certainly, I think, enough evidence that demonstrates that even 1 out of every 10,000 is still a relatively is a number that we can continue to reduce. We can look at things like making sure that our pasteurization is actually being functional. And I'm going to use a non-human food issue here and bring up an example where a dairy farm in Texas was feeding milk to its growing calves. They were actually utilizing a pasteurizer. Problem is that the pasteurizer was not actually functioning properly, and they spread bovine tuberculosis from their cows into their young calves. And so there was an inordinate number of calves coming up TB positive during a USDA TB investigation. And it came back to the issue of their control step of the pasteurization wasn't working. And they didn't have in their processes a check on that pasteurizer to see that it actually was doing its job. And so, we're probably from a dairy perspective, looking at that bacterial contamination, we want to make sure that our pasteurization is working, whether it's on the farm for farm uses or in our plants. And this probably gets me back to my last comment, which is, National Milk Producers Federation has a strong stance against the sale of raw milk to consumers because of that food safety issue. And I know that it's not everybody has the same passion that we have for trying to make sure that we don't have dumb laws passed in places, trying to do good things for dairy farmers that end up doing bad things for dairy overall. It's one of the few issues that we do get involved at the state level. Our association works at the federal level, but raw milk laws are something that we work against at the state level. And just this year, we've been involved in at least 3 states trying to pass laws to enable raw milk sales direct to consumers. That we've joined with the International Dairy Foods Association, the processor side of the industry, in a joint process saying, no, that's just not good for food safety, and it's not good for the dairy industry.
Well, thank you, Jamie. We appreciate the information, and that was a heavy lift on the vocabulary. Those were,
yeah,
a lot of new words to.
That DCD one from New Zealand was interesting. I still can't pronounce that.
Yeah. Well, and I think you're right. That was you try to do the right thing, and it doesn't always work out. So very good. I'm going to put this slide up. That's an evaluation of Jamie's presentation. I'll leave that up for a minute.